The laws of nature are the mathematical thoughts of God. This was stated by Euclid, a Greek mathematician living 24 centuries ago in Alexandria. He wrote the Elements, possibly the most influential work in history. Proclus claimed Euclid, who lived in 450 AD, was the father of geometry, the last major Greek philosopher. He wrote, "Not much younger than these pupils of Plato is Euclid, who put together the Elements, arranging in order many of Eudoxus's theorems, perfecting many of Thytetus's, and also bringing to irrefutable demonstration the things which had been only loosely proved by his predecessors." This man lived in the time of the first Ptolemy. For Archimedes, who followed closely upon the first Ptolemy, makes mention of Euclid, and further they say that Ptolemy once asked him if there were a shorter way to study geometry than the Elements, to which he replied, there was no royal road to geometry. He is therefore younger than Plato's circle, but older than Eratosthenes and Archimedes, for these were contemporaries. In his aim he was a Platonist, being in sympathy with this philosophy, whence he made the end of the whole Elements the construction of the so-called Platonic figures. In the Elements, he states now still common notions of things using words within theorems. The axioms refer to magnitudes of one or other kinds. The types of magnitudes occurring in the Elements include lines, angles, plane figures, and solid figures. For instance, the first common notion could be applied to plane figures and states, if a triangle equals a rectangle and the rectangle equals a square, then the triangle also equals the square. Magnitudes of the same kind can be compared and added, but magnitudes of different kinds cannot. For example, a line cannot be added to a rectangle, nor can an angle be compared to a pentagon. Euclidean geometry says, if two things are identical, that is, they are the same one, then they are equal. In other words, anything equals itself. The way this is interpreted is as a justification of a principle of superposition, and that's used in a proposition. Using this principle, if one thing can be moved to coincide with another, then they are equal. Further, if a whole is greater than a part, that can be interpreted as a definition of greater than. To say one magnitude B is a part of another A could be taken as saying that A is the sum of B and C, for some third magnitude C being the remainder. Symbolically, A is greater than B means that there is some C, and that A equals B plus C. Some of the others are logical variants of each other, and the numbers 1, 8 and 9 are all equivalent to the statement that at least one of the three cases, x is less than y, x equals y, or x is greater than y, holds. Another statement says that two of those cases cannot simultaneously hold. The statement that for two magnitudes x and y of the same kind, exactly one of the three cases, x is less than y, x equals y, or x is greater than y, actually holds, and is called the law of trichotomy for magnitudes. Axioms form the basis of an abstract algebra. Typically, a presentation is given symbolically and in terms of set theory, although set theory isn't necessary. With these axioms, all of the properties of magnitudes needed in the first steps of the Elements can be proved. For instance, if 2x equals 2y, then x equals y, using the same outline that Euclid used to prove his proposition. If x does not equal y, then one of them is greater. After this, Euclid compares magnitudes and pairs of magnitudes of different kinds using ratios. As if pronouncing the certainties of non-Euclidean quantum physics centuries later, the author Fyodor Dostoevsky stated on Euclid, "There have been and still are mathematicians and philosophers who doubt whether the whole universe, or to speak more widely, the whole of being, was only created in Euclid's geometry. They even dare to dream that two parallel lines, which according to Euclid can never meet on Earth, may meet somewhere in infinity."